Welcome, everyone, and thank you for joining us at Coalesce 2021. My name is Amada Echeverria. I use she, her pronouns, and I'm a developer relations advocate on the community team at DBT Labs. I'm thrilled to be hosting today's session, Tailoring DBT's Incremental Strategy to Artsy's Data Needs, presented by Abhiti Prabhahar. Abhiti joined Artsy's data team in November 2018 and was immediately drawn to their incredible data pipeline, which powers decisions across the business. In addition to working on the data pipeline, she also supports Artsy's growth product and marketing teams. Before Artsy, Abhiti was a data engineer at Civis Analytics, where she mainly worked on improving the pipeline of one of their main data assets. And prior to that, she graduated from the University of Pennsylvania, yay Philly, with both her BSc and MSc in systems engineering. At Artsy, DBT's flexibility has made it easier for their analysts to contribute to performance wins in their data pipeline. Over the course of the next 30 minutes, Abhiti will delve into one of their biggest wins so far, which has been finding clever ways to incrementalize their longest running tables while still solving for two main pain points: improving their workflow and modeling Artsy's complex business model. So before we jump into things, some recommendations for making the best out of this session. All chat conversation is taking place in the Coalesce-Artsy-Data-Needs channel of DBT Slack. If you are not yet part of the DBT Slack community, you have time to join now. Seriously, go do it. Visit getdbt.com/community and search for Coalesce Artsy Data Needs when you join Slack. We encourage you to set up your Slack and your browser side by side. In Slack, we think you'll have a great experience if you ask other attendees questions, make comments, share memes, or react in the channel at any point during a BT session. So to kick us off, our chat champion, Erica Louie, the head of data at DBT Labs, has started a thread to have you introduce yourself, let us know where you're calling in from, and break the ice. After the session, BT will be available in Slack to answer questions. Let's get started. Over to you, Abhiti.
Thank you so much for that wonderful introduction, Amada. Like Amada said, my name is Abhiti Prabhahar, and I'm a senior data analyst at Artsy, an online art marketplace based in New York City. Today, I'm excited to share with you how we at Artsy have tailored DBT's incremental strategy to our data needs and what we learned along the way. First, a little bit about me. Amada said, I studied systems engineering and then worked as a data engineer automating data pipelines. I came to Artsy to become a data analyst because I was interested in working on product and business strategy while still being technical. But once I came to Artsy, I was super excited to find that knowing the data pipeline and ecosystem was crucial to being good at my job as an analyst at Artsy. This is just to explain why I'm so passionate about this topic and here today. Now a little bit about Artsy is a two-sided online art marketplace where anyone can buy and sell art. Our mission is to expand the art market to support more art and artists in the world. An average transaction takes place with 3,000 miles between the buyer and seller, and we have 1 million visitors every week. We have nearly 1 million in-demand artworks for sale on Artsy by more than 100,000 leading international artists, and Artsy partners with 4,000 plus art businesses, and we are 260 employees and growing. And finally, here's the team that I have the privilege of working with. We're a team of 7 spread across New York City, LA, and Berlin. Like some of you may have experienced these past 2 years, our Berlin team was hired entirely during the pandemic, which is why we still don't have a full team picture yet, but hopefully soon. Now that I've done the intros, I want to take you back a year and a half ago at Artsy. Imagine this. We're a 4-person data science and analytics team with a pipeline that looked like this. Our daily data pipeline build took around 16 hours to complete. The pipeline powered our BI tool Looker, which served over half our 200-person company on a weekly basis. Our team of analysts had 100% ownership of the pipeline, which meant that anytime the pipeline failed, it would derail one or more analysts' entire day. We had no testing in place, which meant that whenever we wanted to make changes to the pipeline, we'd just cross our fingers and merge the PR, hoping that it wouldn't break the pipeline the next day. And we didn't have the bandwidth or skill set to work on proactive pipeline. As you can imagine, pipeline work was taking up way more time than we wanted it to. We were reactively responding to fires or ad hoc requests, detracting from high impact analysis projects that we wanted to work on and that we had the skill set to tackle. So naturally, for years, we begged to hire data engineers. So in May 2020, when we finally hired our first data engineer, you can imagine how excited we were. The pipeline was finally going to get the attention it deserved, and it did. In Emma's first few months, they migrated the transformation part of the pipeline to dbt, something we had been talking about for years. Then Emma introduced data quality and Circle CI testing. So this was really exciting for us because this meant that when we made these changes to the pipeline, we could be confident that we weren't going to blow up a table or a table wasn't going to be empty the next morning. And they also introduced Circle CI testing, which meant that we had end-to-end testing of our pipeline. The pipeline wouldn't break when we accidentally forgot to add a column name to a table or something like that. And finally, Emma introduced transparency into our pipeline, something that we had never really had before. So we had alerting in Slack to know when the pipeline completed successfully, something we didn't really know unless we went to go check Jenkins. And they also introduced a dashboard for us to just be able to monitor how different parts of the pipeline were performing, if the length of the pipeline was trending upwards, and things like that. So the speed at which our new data engineering teammates were making improvements only made us more enthusiastic. We felt like the pipeline was finally getting the love that it deserved. So after introducing all these changes to the pipeline, we were so excited to figure out what to tackle next with our org's new data engineering expertise. So we went back to our top pain points to figure out what to work on next. Looking back, we realized that we had already tackled most of our top pain points at the time, and that the remaining struggle we had was with the length of the pipeline. So we decided that was the next thing to tackle. So now I'm going to take a step back and give you an overview of our data pipeline, how long it takes, and how we solved for the length. Our data ecosystem takes in data from many different sources. So this is a simplified diagram of our pipeline, but we essentially take data from these three sources: clickstream data, we use segment domain data from our internal systems, and then third-party data. We extract and load that data into Redshift, where we do all of our transformations, all now managed by dbt. So this is where you get hundreds and thousands of lines of SQL to combine the data, enrich it, and then finally output tables that can be easily digested and used for analysis. So these tables are then directly exposed to Looker, where we even do more business logic there to get the data into a format that people across the company can use. We also push some of that data to production. And then finally, we push some of that data to marketing tools as well. The part of the pipeline that we focus on when we talk about the pipeline build time in general is actually this core ELT pipeline, which extracts our domain data into S3, then loads it into Redshift and transforms it within Redshift. As you can see here with these screenshots I have from Jenkins, the extract step at the time of a screenshot, which is October 2020, the extract step was taking 7 hours, the load step taking an hour and a half, and the transform step was taking 7.5 hours. Obviously, each step was taking a long time, namely the extract and the transform steps. But because we were an established data analyst team with a clear understanding of our own pain points and what we were capable of improving, we had total tunnel vision for the transform step specifically. That's where all the SQL lived. That's what we felt like we had the power to actually improve. And so while the extract step and the transform step were taking around the same amount of time, for months, we only focused on the transform step. And we got to a point which I just wanted to point out now, that where towards the end, we started micro-optimizing for the transform step without realizing, oh wait, there's actually also this extract step that we should work on as well. And I just want to point that out because it's a clear reminder of how having the right tools to solve for your problems and the right people with the right skill set makes such a difference in the impact you can have. But for now, I'm going to just focus in on the transform step and how we were able to cut down the build time on that transform step. So this is our transform step. If you work with dbt already, you might be familiar with this document or this screenshot on the right. You can't really see what's going on, but this is actually the dependency graph that dbt docs generates for you. And the transform step is where the data team spends most of our time on the data pipeline, and it's where most of our business logic lives. As of today, we have 316 models to the right here, and it's a crazy web. And greater than 50% of the pipeline build time comes from building one of our most important concepts, sessions. So now I'm going to go into what sessions are, just to explain to you why sessions are so important to us and why it was important to us that we cut down the build time on this part of the pipeline. So What is a session? We take the definition of a session straight from Google Analytics, actually. A session is a group of user interactions with your website that take place within a given time frame. For example, a single session can contain multiple page views, events, social interactions, and e-commerce transactions. It's essentially a container for all these activities. So for example, Artsy is a website of artists and artworks that you browse to find an artwork that you love and might want to purchase. You might come across Artsy through Google search and land on Andy Warhol's artist page. That's your first page view. Then you move to an artwork page, your second page view. You try to save the artwork, which is your first event. Then you follow the artist, your second event, share it with a friend because you love it so much. That's your social interaction. And then you purchase it. That's the transaction. A session allows us to group all of those activities together so that we can then attribute behaviors to each other. So then we can say things like, that purchase at the end came from Google search, or that social interaction towards the end, that came from Google search. To give a little more, here's an example of what sessions help us answer. So what is the conversion rate to purchases for users who arrive at Artsy through search versus users who arrive through email? Sessions allow us to be able to make these types of have these types of insights and analyze user behavior on the aggregate. So we can look at all sessions that arrive through search, all sessions that arrive through email, and calculate the conversion rate. So what percentage of those sessions see an artwork page or that actually have a purchase, and then we can compare to see which channel is doing better. So it's a really powerful tool that we use every day, and it's just completely critical to how we analyze our business. And just a quick example of what this data looks like for those of us who are more visual, this is a much narrower subset of what our sessions table actually looks like, but these are just the core components. So what you see here is we have the unique session ID, then we have the timestamp at which the session starts, then we have a user ID, then the marketing channel that the user came from, then we have all of these like activities or user activities rolled up. So artist page views, artwork page views, saved artworks, placed offers, purchases. And so as you can see here, you can roll up so much data, and this table can get really wide. So we have to be really smart about what data we put into our sessions table and to make sure that it's not too wide, but still has all the critical information we need for analysis. Now I want to go deeper into how we build sessions to demonstrate why this part of the pipeline takes so long to build. So the way the sessions pipeline works, again, this is a simplified visual, is we first take our raw clickstream data, which consists of those page views, clicks, follows, saves, etc. That's mainly coming from Segment. And as you can imagine, we've been tracking our data for around 6 years now, and we have 1 million visitors now every week. So this table is huge. It has 2 billion rows of data, which means that it can take a long time to build. Then the next step is we enrich that clickstream data with information that we need for later on in analysis. We do things like add a device type. We try to figure out what country the user is coming from. We have our own internal tool for deciding what page type it is so that we can aggregate the traffic a little better. So that remains at 2 billion rows again. Then we decide when a session starts. This requires a little bit of logic that we actually mainly take from Google Analytics and have adapted that definition to our own needs. But we basically do time and campaign-based logic to find when the start of a session is. This is when we figure out when a session starts, which means that we are looking through all of this clickstream data to find the one event that we believe started the session. So this is where the table collapses. And so we get actually just 260 million rows of data. And then finally, now that we know when each session, each container starts, this is when then we enrich that session starts data with the sessions information we want to know for our final table. So then we take that domain data from our internal systems and we enrich the session starts table with all the activity we want to know about the user today. What I said before, like page views, clicks, saves, purchases, everything. So our solution for cutting down the build time on these tables has always been to incrementalize them, actually. So you might be asking, what is incrementalization? Incrementalization is the process of transforming only a subset of your data in your table, usually data from the past one day, rather than transforming the entire table. So if you remember from my last, we have some tables with 2 billion rows of data. a few years ago, we realized that wasn't sustainable for us to constantly be dropping the entire table and rebuilding it from scratch every day, because it just took hours to rebuild it. So actually a few years ago, prior to DBT, when we were actually building our transform step in Ruby, we had already been incrementalizing a couple of our largest tables. And that incrementalization was just rebuilding, just adding the last day's worth of data to the table. So before DBT, we had already tackled like a couple of our largest tables. But then with DBT, as you can see with this code here, DBT basically exposed to us as the data analyst team exactly what's going on under the hood. It's pretty much all written in SQL. And so it was really easy for us to understand, oh, we could change this from 1 day to 30 days. We could decide which timestamp we want to rebuild based off of. And so it allowed us to get more creative in how we were incrementalizing our table. So the screenshot I have here is the incremental code, and it's mostly copied from the DBT docs, actually. So if you're a SQL user, it's relatively easy to understand what's going on. And so the data engineer, when we decided, okay, we want to just expand this to the rest of the tables, it was very easy for the data engineer to go ahead and just copy these 3 lines of code, change some variables here and there, and then add it to the rest of our tables. So very quickly, we were able to incrementalize the rest of our sessions pipeline. So we had our entire web sessions pipeline, and then also our entire iOS sessions pipeline, just by copying and pasting this code. But of course, not every story is that easy. Up until now, the data engineering team was able to quickly incrementalize the entire pipeline, bringing the rest of our tables to under 5 minutes. But then we had this one last table in the sessions pipeline that we wanted to tackle. So if you look at this graph, literally all of our tables went to under 5 minutes, except this one final one was still at a half hour. That's the final sessions table. So after weeks of going back and forth with the data engineer trying to incrementalize this final table, we realized that there was something wrong in how we were tackling it, because it was taking too long to figure out what the solution should be. And what we realized as the data team was that we actually had the business context needed to unlock us in this final step. So we took it on ourselves to find the solution. So why was it so hard for us to incrementalize our final sessions table? This is because we have 2 types of data, immutable and mutable data. Immutable data is data that we know is not going to change. It's data like the page views and clicks and follows that I've described earlier that have already happened, making it easy to incrementalize. So for example, you may have seen Andy Warhol's artist page on June 1st. That's never going to change. That's history. And so it's really easy to just rebuild or just add on every day's worth of data, because that's never going to change. Mutable data, on the other hand, is data that's going to change. It's data like how many offers have been confirmed, how many auction purchases have there been, et cetera. So this is data that is essentially, and for our purposes, data that's changing status over time, like purchases. So till now, we had been rebuilding 1 day's worth of immutable data on the left, so with all these tables, and the entire table of 6 years of mutable data. So going back to this diagram, in a previous slide, I didn't show you that we had already actually broken down the sessions table. But a couple of years ago, what we realized one of our teammates had done was they had actually decided that they were going to break out the immutable data from the sessions table and incrementally build that just for some incremental performance win, but then keep the sessions mutable data as is, rebuilding every day. So once we realized that there was this difference in the data and we knew exactly how DBT's incremental strategy code worked, we had to figure out we knew that we could be clever about how we would rebuild our mutable data. To do that, we had to figure out what data points we needed to identify sessions with mutable data. This meant that we needed to take another step back to understand how Artsy's business model works. So the way Artsy works is we have 2 businesses. We have the buy side of our business and we have the sell side of our business. On the buy side, we partner with galleries and auction houses where the galleries and auction houses put their artworks on Artsy to sell. And then under each partner, we have different ways in which users can transact. And each of these takes a different amount of time to change. For example, if you see the contact for price in the yellow box under gallery, that is a transaction where you can start a conversation with the gallery and then continue a conversation, ask them details about the artwork and ask them about the background of the artwork. And then finally it can result in purchase. Because that's a whole conversation, the average amount of time it takes from creation to purchase is 17 days. It takes a really long time to finally result in a purchase. So essentially, on average, 17 days for which that data can change status. Then on the sell side, we have the consignments part of our business where users can submit artworks and sell them on Artsy. And so that takes even longer because you have to submit the artwork. Then we at Artsy have to approve it. Then we have to find a gallery to host it. And then we have to put it up at auction. And then finally it has to be sold. Usually takes like weeks or months to complete. And so we have these 5 types of transactions that all take different amount of time to change status. And because of this is the solution we ended up coming up with. Introducing the open session concept. Naturally, our solution to all this complexity was just a few lines of code. We developed a field called open session, which is built off a condition to only rebuild sessions or rows that had activity that might result in a change of state days or months. If you look at the code here, we have a few columns here where we, looking back at the business model I showed before, these are all activities users can do that can change status weeks or months later. So what we did is we said, okay, if any of these activities exist in a session, call it an open session. And all of these activities had to have taken place in the past 180 days. This timestamp filter that we added was just because we didn't want to rebuild all open sessions of all time, because that would just take way too long. And we decided that it made sense to do 180 days because we knew that would probably tackle over 90% of all of our sessions that had this type of activity. This is what open session looks like in practice. I just included the code excerpt from the last slide here so that you can see what exactly is happening. But like I said before, this is just a narrower version of our table. But looking at this, the columns in yellow are the ones that are taken into account when determining what an open session is. And we look at the session start at to see if it was in the previous 180 days. And then we look at columns like placed orders to see if there were any placed orders. And then based off that, we decide if it's an open session. So the top row doesn't have a placed order, but it is in the previous 180 days. So we don't need that session to be open. But the bottom row did have a placed order and it was in the past 180 days. So that is considered an open session. This is what our final incremental solution looks like for this mutable data. We basically just say rebuild any row where open session is equal to 1 or any row that is in the past 1 to 2 days. And that was just a huge win for us. Again, only a few lines of code. But it was such an exciting finding for us because we as the data team realized that we could actually make these performance wins in the pipeline. So this is what our incremental strategy looks like today. Our entire sessions pipeline is now incrementalized, bringing our transform step down to 5.5 hours due to a combination of the following. We have our immutable data, which we rebuild data for the past 1 day. So that's just the straightforward data on because we know that it's not going to change. And then we have the mutable data where we rebuild all rows that are an open session or all data in the past 1 day. What I wish we knew a year and a half ago from this experience. First, dbt makes it possible for data analyst teams to make performance wins in the pipeline. This was a really big finding for us because we didn't realize that knowing the business logic meant that we had the best knowledge to make the changes that we needed. And making performance wins in the pipeline was also really exciting for us because we couldn't really do that much before. The next thing we learned was that our business logic is too complicated to transfer to another team who isn't working directly with it. This is something that actually we realized through this project, but also something that we could apply to the rest of our work. Something that we've noticed with Looker is that with Looker and the capabilities it offers, we're able to allow anyone in the company to analyze data from their space in the company. And so something I've always realized is that I'm not always the one that's the best equipped, even though I'm the data person, to answer other people's questions in their spaces. Sometimes I realize that other people in their parts of the business might know their data better, and that's because they know how the business works and what the data looks like to map out to that business. So this was like a really fun learning for us to realize this is also true for us. We know some of this data more intimately than other teams do. And so sometimes we might be the best to be tasked with this type of work. And finally, I think it would have been really helpful to work with our data engineers to map responsibilities in our pipeline based off our skills and expertise. With the data world changing as rapidly as it does, and how everyone has like so many different types of skills, it would have been helpful to sit down with our data engineering team to say, hey, this is what we do right now. This is what we can do. This is what we want to do. And then hearing from the data engineering team, this is what they can do. This is what their skill set is, et cetera, and figuring out then what we should each own in the pipeline. So what does Artsy's data practice look like today? We're currently 7 data analysts and 5 data engineers. Our nightly data pipeline takes fewer than 11 hours to. We now actually have split pipeline ownership where the data science and analytics team owns the business logic while the data engineering team owns the infrastructure. Our pipeline maintenance truly accounts for 20% of data science and analytics team's day-to-day work. And data engineering proactively works on improving the data pipeline, which with projects like decreasing the extract step from 7 hours to 2 hours. So if you remember from the beginning of the presentation, I said that because we as the data science and analytics team had total tunnel vision for the transform step, we totally never thought about the extract step and how to cut down the build time there. In the extract step, the reason it used to take so long is because we're extracting data from MongoDB, which is really difficult to do, especially incrementally. But our amazing data engineers with their amazing skill set and their background were able to do that and make this huge win to our pipeline, which was really exciting. Again, proving that having the right people with the right skills, tackling the right job is so important. So what's next for us? Next is expanding our team's work to higher level problems across the organization. Now that we maintain the pipeline more minimally than we used to. And then finally, further developing a relationship with data engineering. I think we're in a unique position where we have this very established data science and analytics team in like relative to how old Artsy is, but this brand new data engineering team coming in. And so we have a lot to figure out how to map responsibilities in a way that makes sense given our history with the company. And so we would love to further develop our relationship with data engineering to improve workflows for rebuilding data from scratch. So now, of course, we've incrementally built all these tables. Whenever we like notice a bug or want to make a change to a table, we have to drop the entire table and rebuild it from scratch. And so we could improve our workflow there. We could implement better alerting when parts of the pipeline are down so that we know when we need to step in as the data science and analytics team or when the data engineering team needs to step in. And then finally, to clarify ownership of our marketing data stack. So that's all I had today. Thank you so much for listening. I'd love to hear any questions or thoughts or feedback, or even how you've tackled problems like these at your org.
Thank you for a great presentation, Abidi. Incremental materializations are not only powerful, but are also one of the most common areas on which we get questions from community members as they're scaling. And so folks, luckily you don't have to fight your way through a crowd to meet the speaker.